Alright, so for number 5, we're actually going to go back to the answer that we got on question number 3. So 5.1, if we went back to 3.1, the equation was y equals 300x plus 9,900. So I'm just going to copy that in that box for number 5. So y equals, different color, there we go, y equals 300x plus 9,900. Right? And what it says, what does it cost to raise a baby from birth to her first birthday? Because if you look at our table over here, the table starts at age 3. We're wanting to know if you went backwards, what would it be at age 0, right, at birth? The other question is saying, what would it be if when they're 18, right, or when you're 18? So this says when you're 18. That says when age is equal to 0. So both of those numbers aren't on the table. 0 is not on the table, 18 is not on the table. So what I'm going to do is I'm going to use the equation we came up with to make a prediction. So let's say 300x plus 9,900. And then what this is saying is that when age is equal to 0. Right? So when x is equal to 0. So I'm going to substitute that in. And I've got y equals 300 times x, which I'm plugging in 0 for x, plus 9,900. Well, 300 times 0 is just 0. And then 0 plus 9,900 is just, well, 9,900. And hopefully now this makes a little bit more sense of why we call the b the starting point. Because if you're like, hey, why is this number the same thing as that number? Well, because that's our starting point, right? So this is if we were to count backwards what we're estimating, and it's just an estimate, but if we're estimating that in that first year of life, the child would cost you almost $10,000, right? 9,900. So I kind of did it the long way. I didn't necessarily have to plug in 0, because if I know that the y-intercept is our starting point, then I could have just looked at that number. So just like I know that the slope, the number in front of x, that tells me how it's changing, right? This tells me where it starts. Now what we want to know is what if it goes out to 18? Because again, look at our table. Our table stops there at 15. We're wanting to know what if you went out a little bit further, right? So, well, let's plug in this case, what we're going to do is we're going to plug in and say, well, what if when x is equal to 18? So I'm going to rewrite the same equation. Y equals 300x plus 9,900. And what we're doing is we're extrapolating. What extrapolating means is that we're making a prediction out into the future. And it is just that. It's a prediction. It's an estimate. Obviously, things may change. But based upon what we have here so far, we're wanting to see what this would be. So obviously, the number's a little bit bigger here, so let me use my calculator to come up with that. So let's say 300 times 18. And then, so we get 5,400, and then let's add back in that 9,900. And then, so what we end up getting is 15,300. So that's our prediction for what it would cost to have an 18-year-old. So 9,900 for a baby, they need less, right? Just some diapers and not a whole lot. 15,300, well, you get a little bit older, you need a little bit more stuff. Or you want more stuff. I don't know if you need it, but you want it, right? So that would give us our answer. By the way, you notice that that number is a little off, 15,300, and you look at the table and it's like, well, wait, that says 16. Well, again, because what we found is that this equation is just an equation that we picked from two pairs. This equation doesn't represent what we would say is the line of best fit. So again, it's just an estimate, so that's why the numbers are a little off there. Had we used a different equation, the equation for the line of best fit, we would have gotten a more accurate number. All right, so go ahead and pause now and try the one in the middle and the one on the right side. All right, so for 5.2, should have got y equals negative 4,200x plus 797,000. Remember, this was the starting price for a house, and then as we moved away from the city, the price of the house went down by $4,200 per mile. So what is it in the middle of the city, right? 797,000. There's your starting point. And then 100 miles away, if you used x equals 100, you should have got 377,000. And And then for 5.3, something, again, the starting point here is even if something's fat-free, it still has calories. So we're saying something fat-free, 80 calories, and then if you plugged in 50 into that same equation, you'd get 830 calories. Obviously, the more grams of fat in something, you're going to have a higher calorie content. All right, so that wraps up number 5.